Perfect. Okay, well, thank you for joining me today for Coffee and Content in Science. If you're wanting to follow along in the slides, please do so. You can do so at the Coffee and Content page on the Professional Learning site. So if you're not sure where to find that, just follow those steps, go to our CSD site under Quick Links, and then the CSD Hub, where you'll find Professional Learning with Learning Services, previously known as PLCs. And then you can click on Coffee and Content, and then under Science, and you'll find all of the resources that we have here that I'm presenting to you. So it will look something similar to this. So Coffee and Content page, underneath you see all the subjects that we are offering today, and the science ones are right here. All of the information that I'm presenting, most of it anyway, has also been added as links down below for you. Okay, so we'll get on with the presentation. So like I said, it is being recorded just so I can post it later on for those that weren't able to attend today. Thank you for putting those names in the chat, and then we'll see who wins the draw at the end of the session. I won't take up the entire hour. I know it's scheduled from 9 to 10. Basically, the idea was to have 20 minutes, maybe 30 minutes of learning, and then letting you look at the resources that I'm providing after that. And then I would stay until 10 o'clock if you have any questions. So that is kind of the plan for today. The reason I am doing computer science is based on the feedback I received at the end of last year when I sent out a survey asking what areas of need we're needing to look at. And for the 1 to 3s, it was computer science. So that's why I chose computer science this time to present. The other area of need that was identified was energy. So if you're looking for hands-on activities for energy, that is what we will be doing on the PLAD days. And the first PLAD day for grade 1 is November 4th, the grade 2 is November 6th, and grade 3 is October 24th. So make sure to sign up for those if you would like more help with energy and the hands-on activities. Okay. Feel free to ask questions at any time. Okay. Just a reminder about the new curriculum website, which you've been there probably a lot. There have been a few new science items added, so make sure to check that out. So just really brief recap. So instead of the previous science curriculum that we were used to, where every different unit was more siloed, it didn't really impact the learning from one year to the next. Now we're looking at more organizing ideas that flow from one year to the next, with space starting in grade 4 and scientific method starting in grade 1. So we have all of our organizing ideas. So computer science is new to these grades. And my suggestion would be you can teach it on its own, but it is an additional unit you would have to do. I would suggest embedding it into matter, energy, earth systems, living systems, whenever you can. Same thing with the scientific method. Okay. I also have the curriculum comparison at a glance. If you would like to see that, that is also posted on the new curriculum, the CSD new curriculum website. Perfect. So we have 6 outcomes, and then one of those is computer science for grades 1 to 3, which is what we're going to look at today. Perfect. If you would like copies of the computer science portion of the new curriculum, I have it linked on this page for you. Otherwise, you can print it off individually if you would like off the new curriculum website. You would just have to input the exact page numbers when you go to print it, but I've already done that for you right here. So it's linked here if you would like it. Okay. So why we're talking about computer science, computer comes from the Latin term computate, which means to sum up, to calculate, or to count. It involves critical thinking, problem solving, collaborating, analysis skills, feedback skills, and more. And the main thing, the most important thing, is that it encourages perseverance within our students, which ultimately, that's what we're working towards. Just kind of a flow from kindergarten to grade 3. What are we looking at? Kindergarten, they're going to learn to interpret instructions. They're going to identify what is an instruction and how to follow instructions. The words that I have bolded underneath are the words that you will find directly in the curriculum. Okay. In grade 1, they will then follow those instructions and learn to build 2- and 3-step instructions. Moving on to grade 2, they start looking at debugging. Debugging is any time that the instructions do not work. So how do they change the instructions to get the outcome that they desire? So they are debugging. They're trying to find out what to remove and what to keep in order to make the instructions work for the desired outcome. In grade 3, then we look at computational thinking, which is problem solving and the creativity put together for them to be able to computational think with the relationship between the problem solving and the creativity. When we're talking about kindergarten to grade 1, anytime we're talking about following steps or instructions, we're really talking about an algorithm. Algorithm isn't mentioned yet until grade 4, but really that is the beginning of an algorithm. So grade 4 here, we see an algorithm. So the exam and apply design of processes to meet the need. So what steps do we need in order to get the desired outcome? Okay. When we look at grade 5s, we start talking about block coding and all the language that's associated with that, including loops, which I will show you in a minute what those are. And computational thinking meets abstraction. So when we're talking about in grade 6, the theory or the concept of abstraction is making the instructions as simple as possible for the desired outcome without all the added things that may not be necessary. Okay. So what coding language do you need to know in order to meet those outcomes? I have them listed here. So for kindergarten to grade 1, we're talking about inputs and outputs. Grade 2 is when they start talking about debugging. And then grade 4 and 5 is when we officially become known, or we work on the algorithm language, as well as events and loops. But all of those really are tied together all at once. But these are the specific terms that you would find in the curriculum for those grades. And then putting all of that together for grade 6. Perfect. So this is an example of just an algorithm we could be running, just as a brief example. So the very first off, the start button, that would be our event, our first event. We need an event in order to start the instructions. Then whatever input we have here in this example, it's right, left, and then hand clap. So that's just simply inputting the instructions. A loop could be the amount of times that action is going to be repeated, or in this instance, it could be forever. The loop could go forever until we have the second event, which would then stop the action. And then the output, it is whatever it is that the action has been done following these instructions. And then debugging, did it work or did it not work? Okay, so at the elementary levels, this doesn't necessarily have to be in coding language like you see it here. It could just be in instruction form. Okay, so looking at those instructions into kindergarten, what are the instructions? Where can we find them? Why do we have them? Simple thing like even lining up to go outside. Why do we do that? What are the steps for lining up? At snack time, what are the steps to gathering our snacks? All of those different instructions with the different steps are algorithms. So just having the students identify what those are and being able to follow them. In grade 1, same thing, moving up to 2-step and 3-step instructions. And then they could then create their own 3-step instructions or more if they're capable of more than 3. Okay. Beginning of grade 2 is when we're looking at the creative thinking aspect of it. So can we make different steps in order to get the same result? For example, if they're going to get their snack, are there different steps they could follow in order to get their snack, or does it always have to be the exact same steps for everyone all the time? It doesn't. And so having the students recognize the different ways they could accomplish the same task, that's part of that creative thinking. What do they do if it doesn't work? That's part of that debugging aspect of the creative thinking. If they're not able to get their snack following those steps, how do they fix it? If they run into a problem, is there a different way to solve that problem as opposed to just following one set step of instructions? When we start looking at grade 3 and above, we start looking at creativity and originality. Frequently, students will think that they're not creative if they're not artsy, if they're not able to draw. Or if they're not able to craft, or those things don't interest them. In this slide deck, you can click on the image to get access to it. It's a slide deck made by ARPDC, now known as the consortium. And in it, it just guides students through what originality is and what creativity can look like. It's not just the ability simple to be able to draw. So having the students believe that they can all be original and they can all be creative in different ways. So feel free to use this slide deck. When we're talking about computational thinking in the curriculum, it is a big part of grade 3, and all of these different components they will need to know, especially for getting into grade 4 when we're talking about the algorithms themselves. It isn't explicitly stated what the different components are in the new curriculum, so I suggest following this slide a little bit more, especially if you're doing grade 3. I find that in grade 3, the information around computational thinking is a little bit lacking. So basically what computational thinking is, the first part would be decomposition. So breaking things down into smaller steps. So for example, even identifying what is the very first step, what is the very first event. Then the second piece of computational thinking for grade 3 will be looking at similarities and trends. Are there steps that can be repeated in order to get the desired outcomes? Also known as sorting and categorizing. Okay, pattern abstraction. They don't necessarily need to be very familiar with it in grade 3, although it is part of computational thinking. But like I said, that'll show up more in grade 6. But basically, what are the steps that they absolutely need as opposed to making it more complicated than it needs to be? So it's like a simplified version. And then the actual algorithm design, the step-by-step instructions, putting that all together for computational thinking. And like I said, grade 6 is where they find that abstraction. Different highlights of the curriculum as you see it here. So the different knowledge, understandings, and skills and procedures. I've included kindergarten just so you can kind of see the flow into grade 1. The different slides, feel free to take your time to go through these. Basically in grade 1, we're highlighting that instruction aspect. In grade 2, we start building on the creativity, the design instruction. And then grade 3, that's when that computational thinking is really starts to take shape. Okay, a few resources to share with you. So afterwards, after this session, feel free to click on the different links in these resources pages to have a deeper dive. Okay, so anytime you don't necessarily need tech to do the computational thinking or to do computer science in general for K to 3. Anytime there are steps to follow, that's basically algorithm. Those are basically algorithms. That's computational thinking. So there's different ideas here. There is the use of binary codes with zeros and ones, which can then be transferred into different colored beads for students that they have to follow a different code in order to give themselves a language or a message. So this bracelet here would be a student's name based on the different colored beads that they followed using the binary code. Zeros being pink and ones being blue as an example. The bitmap art coding is kind of interesting. If you click on the image, it'll take you to the lesson, which involves that. It's basically instructions on how to remove and place sticky notes for the desired design at the end. And then there's also cup stacking algorithms. It gives the students the code, so an image of the stacked or unstacked cup, so top or bottom, and how to either add a cup or remove a cup, again, for the desired outcome. So again, not any tech needed for any of this. Okay. There's also coding stories where the students would have to code the events of the storybook that you are following. There are many different coding stories. You go to YouTube, you plug in coding stories, you'll have many, many different examples, which is an interesting way of incorporating computer sciences into your LA. Okay. When we're looking at the tech aspect, there are various websites. Feel free to click on any of these links here to get taken to these websites. Some of them are block coding. Even though block coding isn't introduced until later after grade 3, you're more than welcome to use it ahead of time if you feel that your students are ready for it. Through CSD, we also have the robots that you can sign out through IMC. So we do have the Botley for kindergarten to grade 3. The dot and dash would be probably more appropriate for grade 2 and up because it uses block coding, but we also have Q, which is available for grade 6 and up. We will also be getting B-bots that have just been ordered, and they are similar to Botley. Botley follows a path, either a line path or a coded path that the students would use higher up in grade 3. The B-bot is very similar. It just looks different, but it looks like a bee, and the kit comes with multiple bees that could be coded at once. And that will be coming to IMC. So keep your eyes open for that. You can also order toys or any other robots from the ATA library. They would be delivered right to your school, and you would just send them right back when you're done with them. Okay. A couple additional sites that are fairly interesting. If you're wanting to see examples of artifacts, when the program talks about different artifacts, different things that students could design to meet a need, this is a great website to show examples of what those could be. The second website that I have here is also very interesting. It's really up to date now. So I think I'll actually go into it to show you. So this one is Let's Talk About Science. So it is available in French or in English. They have updated it to meet the new curriculum. So we've already selected Alberta here, and you can select whatever grade. They are still populating it, so there may not be tons for your grade, but let's just try grade 3. And then see, as you can see, it comes up with Science 2023. And then the options will be down below of any courses that would meet, any lessons and activities that would meet that need. So I highly recommend that you check that out. It is new. They've just started going through those and adding those. Some really great lessons in there. Yeah. Another new resource you may not have noticed in the New Learn Alberta site is Stepping into Science. Right now it's only available in English, but there is the second image here on the screen is the French version. It's not quite as populated as the English, but they are working on it. But Stepping into Science, you can click on those. Once you are logged into New Learn Alberta, you'll be able to open those resources, and those are lesson plans, and they have them right now for kindergarten to grade 3 for almost every organizing idea, and there are some for computer science. So feel free to check those out. Okay. And that's it for today. If you have any questions, willing to answer them, absolutely. If you wouldn't mind, it would be great if you could just click on that Coffee and Content feedback form. It is also listed on that Coffee and Content page with the science on our PL website. So feel free at the end, click on it, let me know kind of your feedback for the session. Maybe what you're looking for next time, if the time worked for you, yeah, or if you would just much rather have pre-recorded sessions instead of live sessions as well. That would be really great to note. I'm just going to stop the recording.